So the last operator we're going to talk about in this part of the lesson, this section, will be yet another terminal operator that appears in the observable class. Recall that before we talked about the blocking subscribe terminal operator, and now we're going to talk about the subscribe terminal operator, which terminates an observable stream and will trigger all the processing of operators in the stream, but will not block. So unlike blocking subscribe, which blocked, surprise, surprise, this version does not block. And that leads to some very interesting things we have to do to make sure everything works properly. So the subscribe operator subscribes a couple of consumers and a runnable to the current observable. You can see here it takes a bunch of parameters. These parameters consume all the elements in the sequence that complete correctly using the consumer. They handle any errors that may occur through the error consumer, and they react to completion by this complete consumer runnable. This particular use allows unbounded demand for subscriptions. It'll send it as fast as it possibly can, and the subscriber just has to keep up, or subscribers just have to keep up somehow. Recall from our earlier discussion that the way that things are emitted here is we can have 0 or more calls to the onNext method, followed by 1 optional onComplete call or 1 optional onError call. Those are mutually exclusive, but you might not have anything. So either you're going to get an infinite sequence of stuff followed by onComplete or onError, or you'll get nothing at all, or you'll get an infinite sequence of stuff not followed by onComplete and not followed by onError, and all the other combinations that are described in that regular expression. The value that's returned from subscribe is called a disposable, which indicates that a task or a resource can be canceled or disposed. It is used kind of like it's kind of used as a manual destructor, so you can free up the resources that are allocated by processing things in the stream. In fact, you can actually combine a bunch of disposables into something called a composite disposable, and then you can dispose of them in one fell swoop. And we'll see some examples later that illustrate how to do this and why you would do this. The subscribe operator, in addition to sort of terminating the stream and providing a conduit for onNext, onError, and onComplete events to be handled, also triggers all the other processing of the other operators in the stream. So nothing runs, because remember everything's lazy, until subscribe is hit. And when subscribe is hit, it's like the green flag goes down in a road race and off they go. And at that point, then things start to get pushed from the publishers through the subscribers. Now, there are 3 different lambda expressions that are shown here. The first handles normal processing, and you can see what we're going to do in this case is we're going to generate an observable containing a stream of big fractions that are transformed from a list of big fractions to a stream of big fractions. We're going to multiply each big fraction by this big reduced fraction, which is a constant, and then we're going to handle it with the subscribe method. The first set of handling stuff here is going to simply append the mixed fraction form of the big fraction to the string builder, which we've got here. That's normal processing. If something goes wrong, we do error processing, which is going to append error and then display the results, which we left off because it would overflow the screen with the slide formatting. And then the final runnable that we provide here will be called back to handle completion. So when things are done, then this particular runnable lambda will be called back, which will display the results in a string format. Very important to remember, calling the subscribe operator will not block the calling thread. So basically what will happen is it'll just start running, the subscribe will just return, and things will keep running in a different context until the upstream terminates normally or with an error. And because of the fact that subscribe doesn't block, it motivates the use of the async task barrier framework. So we talked before about async task barrier and how async task barrier could be used to have a whole bunch of things that are running asynchronously be completed when everything is done. And so there are various ways to make all this stuff work, but keep in mind that subscribe doesn't block. And that can be a source of some consternation when you're first learning about RxJava or learning about Project Reactor for that matter. There are other versions of subscribe that have different capabilities. For example, this version can allow you to pass an observer to subscribe. An observer is a data type that has some hook methods on it, and you can implement more sophisticated ways of handling various events on next, on complete, on error, and so on in an object form rather than providing them as lambda expressions to the various parameters to subscribe that we looked at earlier. Project Reactor has a subscribe operator that works very, very similar to the one from RxJava, the main difference being that there's no blocking subscribe in Project Reactor at all. So there's subscribe in both of them. RxJava has blocking subscribe. Project Reactor does not have blocking subscribe. And that's a little bit curious, and it can be frustrating, but that's another thing that motivates the use of the async task framework to handle things properly in that context. As I mentioned before, there really is no equivalent in Java Streams. So subscribe is a terminal operation, but the terminal operators that are in Java Streams are typically used for blocking calls, unless, of course, you have something like collect that's used with completable futures. But even there, you can kind of chain together completion stage methods to handle those things. But in general, with the mechanisms available in Project Reactor and RxJava, they're designed to be asynchronous, wholly asynchronous. Okay, so that's the end of the discussion of key terminal operators in the observable class.